So section 4.5 is about interest. And so this is a good application of why you would want to use exponents and logs is calculating interest in certain types of accounts. It can be savings accounts, money market accounts, lots of different kinds. Okay. We will talk about A and B today. Applications A and B, and then we'll do C and D on Monday. There will be some formulas you have to memorize. I will tell you which ones. You'll be given a lot of formulas in this section, but you only have to have a few of them memorized. Okay, so these will be, you'll see these objectives as we go along too. So simple and compound interest. So we're going to start with simple interest. Here is your formula. This is a formula to memorize. So I'm going to put a star by it. This is simple interest. This is the simple interest formula. Simple interest, it's just basically you put in a starting amount, you're given a rate, an interest rate, and it's for so many years, and you just multiply all those together. Okay, that gives you your total interest. So these formulas down here, those are nice to know, but you don't have to memorize them because you can get them from the one you have to know. So especially this one. So simple interest is the only interest formula that starts with I and not A. So this just calculates the total interest. But then if I want to know the total amount I have at the end, then I have to take the interest and add it to my original amount, my original principal. Okay, so I stands for your total interest. P is your principal. That means your initial amount that you invest or that you start with. Initial amount. Okay. R is your interest rate. This will be a percent, but whenever you're calculating it, it has to be in decimal form. So you always have to change your percent to decimal form. T stands for time, which will most likely be years. And then A, this is your final amount. simple interest formula you have to memorize does not have A in it. If you want A, you take this value and add it to your original amount, which is, that's why this is here. So this is helpful to know, the one I have here in green, but it's not necessary to memorize because you can get it from the red one, the one you have to know. All right, so if you're doing a problem and it says simple interest, this is the formula you use. Okay. We have interest compounded annually. So we're going to start talking about compound interest. And I'm going to scroll down to this one. Okay, you can look at both. So here is the second formula you have to have memorized. So write this one down first, and then you can write those other two above. But this is the other one you have to have memorized. So compound interest is different than simple interest because simple interest just tells you, okay, this is calculates the interest one time at the end of the time period. Compound interest calculates your interest every year and adds that to your principal. So your principal becomes a different amount each year. If you cannot read, that exponent is NT. NT. It's kind of blurry, so it's NT. The variables mean the same thing as above, but we have one additional variable we have to talk about, and that's N. So N is the number of times interest is compounded per year. I'll go back up to the annual interest in just a minute. So that being said, if we're talking about annual, so if interest is compounded annually, then N is 1. It's compounded one time per year. So that's why we get this formula here. And again, this one is just nice to know, but not necessary to memorize. Because if N is 1, R divided by 1 is just R. And N times T, T times 1 is just T. So this is just a simplified form because it's annual and it's just 1. Okay, but this is the one we have to know because it'll work. We'll be able to get this one in green based off this formula. Okay? So we have annually. If you have biannually, so if interest is compounded biannually, N would be 2. Okay? Quarterly, what would N be? 4. Another one you could see would be monthly. N would be 12. Yep. Possible you'd see daily. If you have daily, N would be 365, unless it specifies it's a leap year. But if it doesn't, then you use 365. So those are 2 formulas we have to have memorized. We have a total of 3. And so we'll start with these 2, one for simple, one for compound. your book will give you the formula to use for that specific problem. I'm going to go through and just use the formulas that you have to memorize and show you how to get the amounts that way. So what I note is that this says simple interest. So the formula I need is I equal PRT. Okay, then I want to know the variable I'm looking for. So it says find R, so I'm looking for the interest rate. So that means I have to have numbers for I, P, and T, and in this problem I do. So I, 1928.75, P is 8,500, and T is 3.75. Okay, so let's plug in. So the reason why you want a calculator is because we're going to wait to do all our rounding till the very end. With some of these problems, where you round can make a big difference. So that's why we want to wait to the end. That would give us the most accurate answer. So 8,500 R and 3.75. Okay. So to solve for R, I need to divide by 8,500 times 3.75. I do have to put that in parentheses, so I'm just going to use the times sign. If you keep that 3.75 in parentheses like this, then you just need you get an extra set. And you have to do the parentheses because you want those to multiply before you divide. So for interest rates, I will go out at least 3 decimal places. So I'm typing in 1928.75 divided by parentheses 8,500 times 3.75 close parentheses. And I have 0.061. Most of the time, though, when we have our rates, they're given to us in percents. So this is the decimal form. So the rate that I started with would be 6.1%. Yes? Yes, so that's what we want to, what'd you get? Was it close? Yeah. Okay, you want to wait to do rounding till the very end. Make sure that you have everything typed in. Let me make sure. Did everybody else get this? Okay. Check back over what you have, and I can look at it in a little bit. Okay. So we're going to look at this problem. Again, it gives you a formula to use, but we're going to use the one that you have to have memorized. So I see simple interest, so that means I'm going to use this, PRT. Okay. was the annual interest rate. So what variable am I solving for? I need to find R. I'm looking for the rate, annual interest rate. So I'm looking for R. So that means I need numbers for I, P, and T. I'm going to wait on I for a second. How much should we start with? 50,000. What was the time? Okay. So I, remember, is your interest calculator, not your final amount. So if my final amount was 62,500 and I started with 50,000, then I can find the interest that I got by subtracting. So I have to do that extra step. So that tells me 12,500. And now we plug those values in. So simple interest is the only formula that doesn't start with A. So you have to do that little extra step to find I. Okay, now 50,000 times 3 is a whole number, so if you do multiply those first, it's okay in this situation, but I just think it's good to get used to waiting to round, waiting to doing everything at one time. Okay, so we should have gotten 0.083 repeating. It's rate, so write your final answer as a percent. So when you're doing the calculations, it's in decimal form, but when you're given the answer, then you want to put it back in percent form.
Why do you have to subtract I?
Because I stands for the total interest that you have that you've accumulated. I is the total interest you've accumulated. So your original amount is the interest you have with plus what you started with. Okay? And so what I was given in this problem, the 62,500 was my final amount. Okay, so to know what interest, I would subtract what I started with, and that's the amount of interest I have. So good question. That is something that you'll have to think about doing. But like I said, simple interest is the only formula that starts with I and not A. Okay. Okay. So I see compound interest. I see compound. So again, it tells me I can use this formula. This formula is one of the ones that they've simplified. But for compound interest, I want to use the one that works for any type of interest that's compounded besides continuously. So this is the one you have to have memorized. So that's what I start with, is start with the formula you need. Then Identify the variable that you're looking for. Okay, so read through. So you want to know how much should be invested now. So what variable would that be? The number of times it's compounded per year. Nope. Yep. So we're looking for what we're starting with, our initial amount. That's P, that's our principal. So I need numbers for A, R, N, and T. So how much do I want to have? What do I want my final amount to be? 25,000. What's the rate as a decimal? So you have to make sure to change it to decimal form. I mean, there is a decimal point, but this is still percent form. So you have to make sure you move it to the left 2 places. Okay, so 0.06375. Do not round that number. Okay, you always have to keep it out. And how many times it says annually? This had said annually, so it's compounded only 1 time per year. And then T is the number of years. So how many years? 10. Okay? All right. We want to wait to do our rounding to the very end. What I have here after the P, this is a number. Okay? So I'm going to do 25,000 divided by this number. When you go to calculate these, calculate the exponent either to the side or in your head. Don't type in the 1 times 10 in your calculator because you'll need an extra set of parentheses, and that just gets confusing. So go ahead and do the 1 times 10, which is 10, in your head. And you know this divided by 1. You could do that in your head as well. But okay, so P. So I'm going to do 25,000. 25,000 divided by parentheses 1 plus 0.06375 divided by 1. Again, divided by 1, you don't really need to write that, but you can. To the 10th power. Okay. So I have 13,475 principal. What is that's money, right? What we're starting with. So I'm gonna put a dollar sign and I'm gonna round to 2 decimal places. 0.48. What you guys got? Questions about that yet? All right, we have one final formula you have to have memorized, but first, so we'll go back up, but first, let's do this one. I read compounded monthly. So I first identify the formula that I need. So compounding interest would be this formula. And then I want to know what variable I'm solving for. Which would be what? P. What principal? So I'm looking for P again. So A, R, N, and T. So what's my final amount? 1,000. What's my rate as a percent, or I'm sorry, as a decimal? Good, 0.08375. What's my N? How many times will it compound per year? 12 monthly, so 12. And for how many years? 10. Okay. So I'm going to divide 20,000 by this whole thing, so I can round at the end. Do 12 times 10 in your head or to the side. So 12 times 10 is 120. So go ahead and write 120. Okay. So in the calculator, type in 20,000 divided by parentheses 1 plus 0.08375 divided by 12. Close your parentheses. Raised to the 120. I got 8,681.04. Right around the 2 decimal places. Everybody getting that? Good. All right. So we have simple interest and compound interest. We have another compound interest formula, but this is a specific compounding interest. This is for compounding continuously. So all compound interest use the ones we just did, except if you see the word continuously. If you see continuously, then you will use this one. You probably maybe called it PERT. So it's PE to the RT. RT is an exponent. That is the last one you have to have memorized. And this is specifically for continuously compounded interest. So this is the reason why we have the number E. Okay? And keep in mind, E is a number, not a variable. So A, P, R, and T mean the same thing as it does for all the other formulas. Okay. So if we do a problem, it will tell us that it's compounding continuously. So I see that. That tells me I need use PE to the RT. So, I need to figure out, it says what principal, so what variable am I looking for? So I need A, R, and T. E is not a variable. You're not plugging in a number for E. E is a number. So this is like 26, the one we just did. So my final amount is 20,000. My rate is 0.08375. And 10 is the number of years. Okay, I'm going to divide both sides by E, the 0.08375. Work carefully. Earlier today, I did this problem and I got it wrong because I forgot to type in the 8 with this decimal. Okay, so times 10. I'm going to do just the times sign. Okay, so 20,000 divided by e to the parentheses 0.08375 times 10, close your parentheses. I got 8,655.82. Alright, so it said compare your results to the one we just got. So continuous interest is just compounded constantly. Like that's what that means. It's just constantly compounding. So your A or your P, your initial value is just growing continuously. Where this monthly, it's growing once a month. So not as much. Now there's not a whole lot of difference between these, but the longer it goes, the bigger the difference will be. This is the initial investment. P is what you initially invest. So if you do continuous interest, you have to invest less than you would if it were monthly interest. So given the choice, you want the account to be compounding continuously. Questions about that? All right, so we're just work on some practice problems. Right, keep going in your notes. Okay, what type of interest? Is it simple interest, compound interest, or compound continuously? Simple. So that's what we want to identify first. And start with your formula. Then pick out the variable you're solving for. The question says, how long did it take? So what variable am I looking for? T. Good. So I need to plug in numbers for I, P, and R. Again, I'm skipping because the simple interest is I and not A. How much should I start with? What's P? 50,000. And what's my rate as a decimal? 0.0455. Okay. I needs to be what your interest was.
Well, I love you.
Okay. Just didn't want to be here.
Yeah.
Okay. So she finished with 62,500. So her A value was 62,500, and she started with 50,000. So again, to find my just interest, I have to subtract those. So it's the same interest as that first problem we did, 12,500. Okay. Okay. I'm going to divide by 50,000 times 0.0455. Again, if you do get a whole number, you can multiply first. But I think it's easier to just do all the calculation at the very end. All right, if you're solving for t for number of years, one decimal place is fine. And we should get 5.5. What have we got? So 5.5